Hey Algebra 2, having a hard time keeping my videos under 15 minutes for YouTube, so I really need to do this one kind of fast. But I just want to talk to you a little bit about natural logs. And natural logs, ew, isn't that an ugly color? Natural logs are written as natural log ln, and they are base E. And they're different than other logs with the LOGS because other logs can have an infinite number of bases, whereas natural logs is restricted to only bases of E. And you might think, well, where would you use those? Well, the way we write it, we can turn anything we're working with into natural logs of base E, and they're very easy to solve. Much easier, in fact, than having to use a change of base rule. But what I want you to see, too, is something really neat like this. What if I took the natural log of E base E? Well, if we started with E and we ended with E, what exponent got us there was 1. So whenever you see this, the natural log of E, that will always be equal to 1. Now let's show you some easy simplifications that we can use using natural logs. And here's a simple example. Let's do a better color. What if I have 4 raised to the x power, and that's equal to 5? Well, definitely we do not have hope for like bases on this one. So we come in and we do this. Step 1, you write natural log on one side of the equation. And what you do to one side, you do to the other. Well, wow, that's got natural log of 4 to the x is equal to natural log of 5. Guess what base we're in? Yeah, we're automatically in base E by just writing natural log. Now we're going to use our power property of logs and bring down x. So x is now natural log of 4 and natural log of 5. And we're going to be doing something simple. We're just going to be dividing both sides by the natural log of 4 and natural log of 4. So you put that into your calculator and you end up with a grand total of 1.1610. If you take it to 4 decimals, how easy was that? I'll make that approximate. That's kind of wicked, isn't it? Let's try something a little more robust. Let's try a exponent that's a little bit bigger. And let's take 2 raised to the x plus 1. And that's going to be equal to 3 to the x. And you're going, okay, Ms. Coons, we're going to write natural log on both sides again. And I'm saying, yes, you are. You're going to write natural log of 2x plus 1 is equal to natural log of 3 to the x. And we're going to use our wonderful power property again, and we'll bring those x's down. But this time I have a partner with this x. This is x plus 1 times the natural log of 2. And over here we just have a single x times the natural log of 3. I know both of y'all, or all of you, want to start dividing both sides by the natural logs, but we can't do that just yet because of this one. It's actually easier if we distribute the x to the natural log of 2. So here we go. That gives me x natural log of 2 plus the natural log of 2 is equal to x natural log of 3. And you're going, I don't see it, Ms. Coons. Well, it's hidden right here. I have an x in front of both of those terms, and I want them on the same side of the equation. So I'm going to subtract a little and add a little, and I'm going to end up with this. X natural log of 2 minus x natural log of 3 is equal to the negative natural log of 2. I just move some things around. You can slow this down a little later and find out what I have done. But now I'm going to do factoring out these x's. And then I'll have only one x. And that's the reason why I did this. I had x's on both sides of the equation, and not only that, I had 2 of them. This is the only method I have to get x to 1x and be easier to isolate. So this just becomes natural log of 2 minus the natural log of 3 is equal to negative natural log of 2. No, I can't cancel those natural logs of 2, so don't even think it. But I can divide both sides by this monstrosity over here of natural log of 2 minus natural log of 3. And believe it or not, it's longer to write this out than it is to solve it. This is gone, and that's what x is equal to. And you can put this on your calculator. X is going to be equal to the negative natural log of 2 divided by the natural log of 2 subtract natural log of 3. So you put that into your calculator, and when you do that, you should end up with this wonderful number of 1.7095. Try that and see if it works on your calculator. And if it does, you're doing great. Now I'm going to go into an application problem, and we're going to visit a city that is infected with rats. There we go. Big old ears, little funny whiskers, and a big old tail. Okay, here we go. This city has 30,000 rats at this time. And let's put rats. These guys are doubling every 5 years. We want to know when, I don't know why we want to, but we want to know when the population would be 1,000 rats. So how we're going to set this problem up is simply using your base formula for exponents. So here we go. Our initial amount of rats, 30,000. Little tiny feet scratching everywhere. And our rate of change is 2. And that stands for 200%. Time, I don't know in the future, but I do know that every 5 years I end up with double the amount. And my question was, when do we get to 1 million mice? Okay, so the first thing I want to do is, we're going to go do some old-fashioned algebra and divide both sides by 30,000. And when I do that, that cancels on this side, and let's go zero hunting. And I get 100 over 3. And I'm not going to put that in decimal form, I'm just going to keep it. And 100 over 3 is equal to 2 raised to the t divided by 5 power. Ew, I have an unknown in the exponent. So super log, we're going to take the natural log of both sides. So the natural log of 100 divided by 3 is going to be equal to, I'm going to go ahead and use the exponent power and bring it down in front, t divided by 5 times the natural log of 2. And I'm kind of running out of room here, so I'm going to have to come up here to a little bit higher. I'm so sorry. I'm going to divide both sides by the natural log of 2. So, natural log of 100 divided by 3 divided by the natural log of 2 is equal to t over 5. What can I do to get rid of that 5? I'm going to multiply both sides by 5. And when we do this, we should end up with a pretty cool number. And I'm going to write 5 over here. 5 times the natural log of 100 divided by 3, I put that inside parentheses, divided by the natural log of 2 is equal to t. Class, I really want you to practice putting this into your calculator. It's harder to put in than to actually get the answer. But what I'd like for you to do is come and tell me what you got for your solution next week in class. At what time do I end up having 1 million rats? And see if your answer makes sense, and you can always go back and plug and chug and check it out. But that is the power of natural logs. They're really awesome. They are calculator based to find the final answer, but by just writing the symbol natural log on both sides of the equation, and getting a single log makes life really, really easy. See you next week. Take care.